Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be building what you see on the screen, which is an afterburner rig. I was recently contacted by AlexGo643 who suggested that I build one of these. So the shout out goes to you, AlexGo643, for this one. And in order to achieve the desired result, we're going to be using a combination of MoGraph, Xpresso, thinking particles, pyro, and we'll also be scratching the surface of a bit of redshift. That's what we're going to be about. Now, in the first tutorial, we're going to be concentrating on making the actual nozzle itself, because there's a fair few things that we need to do in order to get this thing to function correctly, because it does have a number of different moving parts. That will be our task for this tutorial, and then in part 2, we'll focus on pyro, and also what we need to do within redshift to get this thing functioning. And we'll also be using the thinking particles, of course, in the second part too, because they're fundamental to actually making pyro generate this effect. That's what we're going to be about in our first tutorial. So without further ado, let's see if we can make this happen. We start by bringing in a cone, and we'll change its orientation to +Z. Just move around so that we can see. Now I've set my display up. I've got it on garage shading lines. I've got it on wireframe as well at the moment. We'll leave that for now. And that's how we want it. And then we can work with this cone and set up its top radius and other parameters. So 15 for the top radius. We don't want caps, so we'll get rid of that. Bottom radius 30. Height 50. Height segments just 2, and we'll leave the rotation segments at 16. I'll just hit O so that we can see the object more clearly. Now, we need 2 more copies of this cone, so we'll command drag to copy those out. And we can then think about where we're going from here. For a start, we need to make them all editable, so I'll hit C to do that. And then we can just switch the second 2 off for now so that we don't display them, and work with our first cone. UL for loop selection. We're in polygon mode, so we can just select all of these polygons and delete them. We can then bring our second cone back in, and on this occasion we want these to be deleted, so we'll select all of those and delete them. And that gives us 2 separate cones, one for this is our nozzle connector technically, and this is the nozzle itself. And our third cone here, we can bring this back for now, and we'll also select it, select model mode, and then we're going to scale. Now the Z, we can switch that off. That doesn't need to be scaled in the Z. And then all we'll do, just by eye, we'll bring it to there. We can easily adjust this afterwards if we need to. So that's got it that far. The next thing we can do is select this cone. So our cone number 1, and we're interested in deleting a number of these segments because we really only want one, because we're going to be using MoGraph. So let's go back into polygon mode, UL for loop selection, and select them all. And then with our brush selection tool, we can just hold down our command key and select this one and then delete them. So we've now just got one segment of that particular cone left. We now need to worry about our axes here. Now we can see at the moment that they're not really in the right place. They're a long way from where they need to be. They need to be aligned along this bottom edge. So we'll select the edge here, and we can see that our axes for that edge are where our modelling axes for the whole model need to be. But we'll orientate those. So what we'll do in our axis mode here, go into our tools, axis center. From our action drop down menu, we do need axis 2. The center does need to be selected edges. Axis, we will use X. And the alignment selected edge. And if we execute that, we can now see we've got a smaller set of axes here, and they are technically in the right place. So let's just select model mode, and we can see them there. But we're not quite aligned correctly because we need to rotate them. We can just do this by eye, it will be good enough. So we'll rotate this and we'll do it. It wants to go around 17 degrees so that it's just facing along the actual object. As I say, by eye is good enough. That's absolutely fine. That will work for us. Okay, so we've got our axes in the correct place. And we can see that that is going to work for us. Okay, so we just select that. Yeah, that's going to work for us. Okay. The next thing we need to do is give this some thickness. So what we'll do on this occasion is simply select the cone, hit D for extrude. We also need to select polygon mode. We've got our D for extrude, so we'll just select that polygon. Now the offset does want to be minus 0.5. So we'll apply that. And now we've got a thickness added to our polygon. The next step is to bring in a cloner, and we can drop our cone into there. At the moment the cloner is set up as a grid. That's no good. We need it to be set to radial, and we also need the plane to be XY, and that's better. We can see that these are arranged correctly now. We want 16 for our count, not 516, just 16 will do fine. And then we can work with our radius, and that needs to be 22.1. And that brings them back to where they need to be. Now, we need to work with our offset. And the offset we can set to 11.75. And in fact, 11.25, I think might be better, 11.25. That's better. And now we've got them in exactly the right place. Fantastic. And that means that we can work with our transform. With our rotation P, we can make them move. And that's exactly what we need to do. Fantastic. So that's all working. If we say minus 17, that gets us to where we want to be. So that will be our starting rotation. And 0, if we move it to 0, that will be our final rotation. That will fully open our nozzle. Now we can see at the moment this inner nozzle here isn't reacting, and that's because we need to work with Expresso and get things sorted out so that we can get this all doing the job properly. We'll bring in a null, rename it Expresso. We'll give it an Expresso tag, but before we actually start doing anything in the editor, we need to add some user data. So we'll select this and add the user data. We can add a group and call it controls. Drop this data into there and call this nozzle open / close. And then we can set up our parameters. We do want a float data type, a float slider for the interface, a real value for the unit. Steps of 1 is fine, and we'll go from 0 to 100. And we'll also clamp our min and max values. Hit OK, and we've got it. We're ready to go. First thing to do then is drag in the Expresso null, and at the output stage in our controls we want nozzle open close. That's ready to go, and we can then think about where we're going next. First thing we need is a range mapper. So we'll bring one of those in, plumb the output of the open close into the input. Now we know that we're getting a value between 0 and 100 out of here, so 0 to 100 is fine for the input range. And then the output range will be in degrees, so we must change this to degrees for our output range. And then we're working from minus 17 to 0, because we know that these are set to minus 17 at their start position, and 0 will be their end, or end rotation I should say. So start rotation and end rotation. Okay, great, so that's our range mapper set up. We can then bring in our cloner, and at the input stage transform, and it will be rotation, rotation, P, connect these two, select our Expresso null, and these should work. And they do. They work great. That's the first step towards making the nozzle work as it should. Now we can see that this inner cone at the moment isn't behaving the way we want it to, and it won't, because at the moment it's an editable cone. What I actually need to do is remove this cone, bring in another one, and this needs to stay procedural, so we can make it +Z, 15 for the top radius. We don't want the caps, we'll get rid of those. We want 30 for the bottom radius at the moment, and we want 50 for the height. So we've got it some of the way. Now we want just make it, well, it really only wants one height segment now. So one height segment. 16 rotations is absolutely fine. But if we just switch to our right hand view, so F3, and hit H so that we can see where we are. We actually need a height of 25, and then we should be able to move this into position. In fact, if we move it, let's have a look. If we go into our coordinates, see where we are, we need to come to here, don't we? Which is 13.5, I think. That should work okay. Let's have a look, see how we are. Might be a little bit too big, I think, at the bottom radius, so we just need to adjust that. So let's do some work here. Just bring this in. So somewhere around there, I think. Let's just check in our 3D view to see what we've got. I don't think it's far off. Let's just have a look over here. Look through the back of the thing. Yeah, I don't think we're far off, are we? We can see that it's pretty much matching up. It doesn't have to be 100% perfect. I mean, you know, by eye is good enough, but I would say that that's matching up pretty well. So we've got that in place. Let's just, with our Expresso, just bring that back down to here. Let's have a look. Right, so our top radius needs to be changed as well. So let's go into our cone once again and change this top radius. Take that down. What have we got there? We're actually a little bit too far forward, I think, so we can probably move this back. Probably try 13. In fact, I think it's 12. 12.5 should be right, because that's half. That's fine. That looks really good. Yeah, okay, at the moment, I would say that that's looking quite nice. The top radius probably needs to go a little bit more, 14.5. Too much, I think. 14.3. Well, that doesn't look far off. I might go 14.2. Yeah, 14.2. I think we'll get away with that. We'll get away with that, I think. Yeah, I mean, again, I'm not looking for absolute perfection here. I mean, if you want to sort of play around and get this absolutely spot on, then please do, but it's good enough. So 14.2 is what I'm going to settle for. Now, in order to take control of this, we need, again, at the output stage of here, we need to say rotation P for our cloner. And then we'll also need another range mapper. So we'll bring another one of those by command dragging, plumb this into here, and then we can work out the parameters. So let's see what we're going to do here. We want -17 at the input stage, so we need to change our input range to degrees. This will be user defined. So our input range needs to be -17. Our input upper is 0 there, so that gives us the full input range. And then we want to work with the radius of this cone. So we said we wanted to start from 14.3, and we can then work from there. Where are we? Oh, that should be 0. That should be 14.3. Okay, that's better. And then we want to go to 22.5. That will be our top output range for our output upper. We can then bring in the cone itself, and we want in our object properties top radius. That's what we wish to work with. We can drop that into there, and that should be fine. That should do its job. Let's see where we are. Yep, 14.3. Well, that's good for, I think I said 14.2, but 14.3 looks actually that bit better. So let's just see what we get when we use our open close. How are we? Are we okay or are we not okay? Might not want to quite go to 22. Let's go to 22.5. Let's go to 22. Yeah, 22 I think is fine for that. I don't think we need to go to 22.5. Yeah, but that's doing its job. That's actually behaving quite nicely. Let's just run that back. Yeah, that's working quite nicely. It's doing what I want it to do. Now, one last thing that we need to do with this cone is make it thicker. So if we bring in fact, hold down the Option key and select a thicken from here. Just want to, in fact, we can't do that. Just drop that out of there. Drop that into the thicken. That's it. Now we've got the thing working. We can see that it's way too thick at the moment. What we want is actually minus 0.5. And that should just about give us a thickness on there, I think. Let's have a look, see if it has. Minus 0.5. Minus 0.5. Oh, in fact, sorry, I want to say minus 0.5. 0.5. That's better. Now we've got 0.5 thickness, and we can see that that's in there. So that's all working as it should and looking really nice. Now the position of it is not quite right. We need to take that back, and it needs to be around minus 70. And that should align quite nicely. Now let's see what happens when we use our Expresso. Yeah, that's doing exactly what I want it to. Yeah, looking really nice. Fantastic. So that's the inner and outer cone of our nozzle all working as it should. The next thing we need to do is bring in a disc. Its orientation should be plus Z. Its outer radius 22.5 and 2 disc segments. And that places it at the correct point within our nozzle. If we make our cloner disappear and also our inner cone disappear, we can see our disc is in place. The next thing to do is hit C to make it editable. Currently we're in points mode. We don't want to be there. We need to just close this down. If we select polygon mode, UL for loop selection, select all of these and delete them. And that's fine. We've got that done. We can then move on and go into points mode. And in our options, we can say that we wish to see point indexes. So our point 0 is here. What we can do with our disk, we can actually rotate it so that we can make our point 0 where point 2 currently resides. So let's do that. If we select model mode and add disk and rotate, what we need to do is, let's have a look, see where we are in our coordinates. We need to rotate, and it'll be rotation B, 360 divided by 16. And now we've rotated to the correct position, and our point 0 is here where it needs to be, just by rotating 22.5 degrees. Right, fantastic. So we know that that is correct. So what we need to do is work with each of our points on this inner radius, because we're going to use this as a kind of iris. That's the kind of thing we're going to be using it for, because I'm going to actually emit particles from this particular disk, and I'm going to use the disk itself to control the angle at which they're emitted and also we're going to control the sort of volume of particles as well by manipulating this inner radius to open and close the iris. So that's what we're about. That's what we're going to be doing. So the next thing to do then is bring in another cloner. That's a subdivision surface. We don't want that. Another cloner. And then we can bring in a null object and drop that into the cloner. And we want to clone 16 times. So we'll set our cloner up. Let's get rid of the coordinates. We'll set our cloner up. We want the mode to be radial. We want our count to be 16. XY for our plane. And our radius initially wants to be 11.5. And that places it, or places our clones. And if we go into transform and select index, we can see where they are. Now at the moment our point 0, or our clone 0, is over here. So if we go back into our object mode, our offset needs to be 90 degrees. And that places our 0 here. Matches up with the 0 that we've got in our disk. And we can see that those two are going to align. That's important, so you must do that. Great, so our cloner with our, what we're going to call targets actually. So I'm going to call this target. And we'll call this cloner targets. We can do some renaming of some of the other stuff as well a little bit later on. Okay, so we've got all of that done. We can just drop this down here. Good. We're now ready to think about working with our cloner here and giving the positions of each one of our target clones to each of our points along the inner radius of our disk. In order to make this function, we need to reach for our Expresso expression once again. Let's just make the window a little bit bigger. And then we can think about where we're going. The first thing I'm going to do is reach for an iteration. Just place that here. And its end point will be at 15. So iteration end 15. Because obviously we've got 16 points ranging from 0 to 15. And similarly, 16 clones ranging from 0 to 15. We can then bring in a data node. So we'll come down to motion graphics here and bring in a data node. Place this over here. Now the iteration can plumb into the index. At the output stage, we need to add a position port. And then we can think about where we're going next. Well, for a start, we need to bring in our targets cloner. So we'll bring this in and drop it here. And at the output stage, give it an object port and place this in here. So that's set up. Now, we need to manipulate the positions and also the radius. And I should say, for clarity, it's the position Z that we're going to be working with here. So what we need to do is firstly come down to transform position, and it will be position Z at the input stage. We can then also add a radius port as well. So we'll come down to object properties, and if we can find it, we'll reach for radius. Oh, we got plane there. I want radius. Delete that one. Radius. So object properties, radius. There we go. So we've got our two input ports set up and ready to go. Moving on from here, once again we need to reach for range mappers. So we'll bring one in, and then we can simply command drag to copy another one. and those are set and ready to go. Now at the moment we can't actually plumb anything into them because we need some more user data. So our next port of call is to create it. We'll select our Expresso null once again and manage user data. Add another group. We'll just close controls, put it above there. And we'll call this Afterburner. And add some data into it and call this thrust. Once again, the data type will be float, the interface a float slider, a unit, our real units, and our step value will be 0.1. 0.1. And we'll work from 0 to just 4 on this occasion and limit the minimum and maximum. At default, we'll leave it 0. Okay, so that's fine. And we've got our user data, and that completes it. This is as much as we actually need. What I will do, if we just go into manage user data, if we draw these away from there, that just gives us a better result. That's what we want. Okay, so we can work from here. The next thing to do then is go into our controls. Where are we? Controls should be there. That's interesting. Why is that not there? Expresso. I've got my control there. Why am I not? Oh, I see, because I've got... Right, okay, I've got 2 user data. Let's go into manage user data. Have I lost controls? No, I haven't. I haven't lost controls. I just need that in there. That's it. Right, let's see where we are now. So if I go into my controls, I've got Afterburner and thrust. That's what I need. And then thrust can be plumbed into both of these range mappers. And we can then think about setting them up. So our top range mapper here, we can set our input upper to 4 because we know we're working from 0 to 4. And then we're going to be actually using this to change the position Z of our clones. And we need them to move between values of -5 to -1. And we can then plumb this into here. And we can see that they have indeed moved. But at the moment it's just the clones because we haven't yet applied anything to the points. We need to apply the positions of each of our clones to the point positions, and we will be doing that a little bit later in the expression. Now our second range mapper here, once again, we can change our input upper to 4, and our output lower, we can make this 22, and our output upper 11.5. In fact, we'll make that 22.5 initially, and we'll see how that goes. And then we can plumb this into our radius. Oh, and again, we can see that our points have leapt to the outside edge of our disk. They're going to line up with that. Okay, so that's all working as it needs to do. In fact, what we will do, I think I will make that 22 because I think 22.5 is slightly too far. So go 22 because I don't want the angle that I'm creating to be too flat. So that's why I'm saying 22. Good. So that's all working as I want it to. Moving on from here, we can add, if we just move this down here, a math node. So let's bring one of those in, calculate math. And this needs to be a multiply for the function. And we need to multiply by 2. So if we plumb the iteration into there, so whatever's coming out of the iteration, we're multiplying by 2. Because if we think about it, if we select our disk, we can see that we've got 0, 2, 4, 6, etc. up to 30. But with our clones, it's 0, 1, 2, 3, 4. So we've got to double this number, otherwise things aren't going to work out. The next thing we can do is actually bring in the disk itself, and at the output stage, give it an object port. And then we need to bring in the all-important node, and that will be a point node. So we'll bring one of those in. If we plumb our disk into here, that sorts that out. Now we also need to give this a point position at the input stage, so we've got that all there. And then all we need to do is plumb this into the index, and straight away they've all gone to the center of the disk. But if we plumb the position from here into there, we get our disk opened out. And we can see that our points have moved back to -5 in the Z, and our inner radius has opened up to 22. And that's what I want it to do. So that's behaving as it needs to. Let's just select the Expresso and adjust the thrust. And we can see now what's happening. So you can see that this is how I'm going to use this. The angle of this is going to be used to create the angle on our thinking particles. And because our disk actually changes its size, we get less area here. So that will control how the points are actually going to be emitted from it. So they'll be more concentrated when it's like this. When it does this, they'll open out and there'll be more area for them to be emitted from. So it gives us that bit of extra control doing what I've done there. And that's why I've done it. So that's really good. That's all doing what I want it to do. Fantastic. So we've got it that far. The next thing we need to do is add another cloner to create what will effectively be the jets which are used within an afterburner, because the way an afterburner works, it actually effectively squirts fuel into the hot air that's coming out of the back of the jet, and it creates extra thrust that way by burning extra fuel at the output stage of the jet. That's exactly how it works. So that's what we're going to set up next. We'll bring in a tube, orientate it +Z, and then we can work with its parameters. The outer radius we'll set to 22, the inner radius 17. The segments on this occasion, the rotation segments, will make 60. We'll make this nice and smooth. And our height we can make 1 centimetre. So it's sitting in there. We can just turn that off now. We don't need that. Let's see where we are. Just turn the point indexes off on that. Okay, great. So we've got that far. In the slice tab, we can switch this on, and we're going from 250 to 270, just to give us a small segment. That's what we want. Now, let's have a look. We're okay. We've got everything we want in there. Height segments, we can just put 1. We don't need more than 1. Do we really need 60 rotation segments? Well, it is nice and smooth, but I think we can go down to about 15 actually. I think 15 will be enough to make that smooth. Okay, so we've got our object. The next thing to do, bring in another cloner, drop our object in. Once again, we need to set this up. So if we select the, oh, we've got a subdivision, don't want that. We want a cloner. Bring a cloner in, drop that in there. Great, so we've got our cloner object and we need to set its parameters. We can make it radial. Once again, it's not in the correct plane, so we'll make it XY. Our count will make 8, so we'll have 8 jets, and we can set our radius down. Let's see where we are. Set this to -1, and that's where it needs to be. And that gives us our 8 jets set up and ready to go. Now our offset, we just need to make -13, and that puts them in the correct places. And if we look, we can see they're pretty much in the correct places now. We could go a little bit further than that actually. We might be able to go, let's have a look. We can go yeah, I think minus 12. That puts them just about in the perfect position, I would say. Okay, so these are our jets. We'll name them jets. In fact, we'll do some housekeeping and start naming everything now, I think. This cloner here we can call nozzle outer. Bring that back in. And our thicken here, we can call this nozzle inner. And then we can move this cone up to here, and for want of a better name, we'll call this nozzle connector. Okay, great. So we've got everything sorted out and named. Okay, so everything there is working as it should. We've got the open close, and we've got the thrust, which is going to control the flow of particles. Now these jets, these will light up. Well, they'll start dark and they will light up and eventually be yellow. And then we'll use the bloom effect within Redshift to actually make them glow. That's what we're going to be about. But that's for our second tutorial. But anyway, everything so far is doing what it needs to do, and we've got full functionality when it comes to our nozzle, and all of the parts of it are made and ready to go, and they all do their job. That's what we need. So I'll leave it about there for this tutorial, because that's as much as I wanted to go through. We've got Expresso underway, we've got it all doing what it needs to do, and we've got, so for part 2, as far we'll as make this afterburner burn, and we'll set it up with particles, and we'll get the thing functioning as it should. We'll get the particles done first, and you can see those things lighting up there. We'll get the particles done first, and then we'll work with pyro to create the afterburner effect. And then of course we'll be working a little bit within Redshift to create a few basic textures and get this texture for the jets working correctly. And of course we'll have to do a little bit of work within pyros, the actual pyro volume here, to get this looking the way we want it to. We won't have to do too much there, but we will have to do some work, and there'll be a few other bits and pieces that we'll need to make adjustments to in order to get the thing fully functional. But anyway, that's for part 2. So that just about completes part 1 of this 2-part series, and I really hope you've enjoyed doing this tutorial and that it's inspired you and given you some ideas for things you may be able to incorporate in your own projects. And if you have enjoyed the video, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one, so I'll see you very soon in part 2.